All right, we're back. We're going to finish off page 51. I'm not saying that as if we're going to do it quickly, because who really knows, but we're graphing cotangent, and let's just dive in. So period, biggest mistake, 2 pi divided by b. We want just pi divided by b because it's cotangent. So don't be that commoner who makes that mistake. So this will give us 3 pi over 4. Not optimistic about this because that is a very small period. And it's fraction, so maybe, we'll see. So 3 pi over 16. X is, so what do we do here? We mentally move this over, so it's a negative 6 pi over 5. Multiply by 3, negative 18 pi over 5. Divide by 4, negative 18 pi over 20, which is negative 9 pi, whoops, negative 9 pi over 10. Let me just check that. 18 over 20, but negative. Yeah. Okay. So now, okay. So what's the common denominator is 80, I think. So that's great. Can we use 40? Nope. 80 it is. So times 5 is 15 pi over 80. Negative 72 pi over 80. All right, so as usual, it's not as bad as it seems. It's not great because we're only labeling every other increment, which means we're really going to be labeling by 30 pi over 80. So we just have to add 30 to the numerator to like make it work. But here we go, y equals 2. We can go up 4 to y equals 6. We can go down 4 to y equals negative 2. Let me count by I really want to count by 4s, but I also really want to get 0 on there if I can. You know what? I'm going to do it. I'm just going to go like right. Oh, no, but then the labeling. All right, let's see. So 6, go by 2s, I suppose. 6, 4, 2, 0, negative 2. And then I can go 2 above, and I can go 3 below, so it's probably as good as it's going to get. Got to start and end at the right place, and you're pretty good to go. And then our starting point is negative 72 pi over 80, which I will put right here. All right, then we go by 30s because we're so we're using, this is our starting point. Use every box as an increment, but only label every other. So this will be negative 42. And then negative 12. Brutal. All right, and then all right, so 18. I feel like that's where you have to be really careful, is when you go from the negative to the positive, where like the pattern kind of breaks for a second. So I get a little nervous there. 48. Also, like, depending on how fast you're trying to do these, like, it's pretty, oh no, what? All right, hold on, we're crashing, but maybe not permanently, maybe, but also maybe permanently. And it's so frustrating. You lose something when that happens. Oh no, not really. Okay. So, I mean, maybe, but where are we going? Let's go backwards now. I think we're still good. So negative 102 over 80. Easy, a lot of mistakes possible here. Negative 132. And then some people, the lazy amongst you, don't even label. And like, I just don't get that. Like, what are you doing? You like making bad graphs? Is that what you're doing? Although I'm tempted to not label the next one because it's another one of those, like, you're doing a jump there. So negative 222, I think. Over 80. And then not labeling that. So yeah, 192 plus 30 is 222. So that should have worked, I guess, is what I'm basically saying. 19 plus 3 is 22. It's really all you need. I'm surprisingly bad at arithmetic, I would say. I'm surprised at how bad I am at arithmetic, but you don't really need to be great at arithmetic to do math. So keep that in mind, all you I was really good in math until 4th grade types. You weren't doing math, you were just learning number facts. see here. Dotting in our fake sinusoidal axis. And then it's cotangent, so it's going to start on an asymptote, which is really annoying. It's also negative cotangent, so it's going to go asymptote, and then it's going to go low, middle, high, asymptote. Excuse me. Allergy season, hopefully. All right, so we're going to start with an asymptote. So I'm going to do the thing where I like try to steal an asymptote. So over here, I'd like to just make it over here so that I can copy and paste it. Then I really wish this app that I'm using is really, it's Notability, it's a great app. Really missing a dotted line feature though, which I feel like if you're taking notes, there's still some applications for that. So here we go, asymptote, and then it's gonna go high, middle, low, asymptote. High, middle, low, asymptote. And then let's go the other way. So it's asymptote, low, middle, high, asymptote. I totally missed that. Wait, I can still move it. There we go. And then low, middle, high, asymptote. And then low, middle, high. Oof, just getting in there. Okay, but I mean, I should put it because it fit, but it stinks, but whatever. All right, so at the start it was an asymptote. Then we go to the low point, which is going to be, did I put that? No, I didn't. Oh, I gotta go 2. This is annoying. Okay, so the low point is down here at -2. And then middle point, and then high point. It's gonna be so much harder to make the graph, you'll see. Stretch it out a little bit, makes it a lot harder. Here. Okay, so one thing you might notice is that this has the feel of a tangent graph, and very much you are correct that a negative cotangent graph is essentially a shifted tangent graph, and we know the reason for that. So the reason for that is that we know that the cotan of x is equal to the tangent of pi over 2 minus x, right? So that's the cofunction identity. But tangent is an odd function. So let's do a little factoring magic here. X minus pi over 2. Okay, and then tangent's odd, so the tangent of negative theta is the negative of tan of theta. So this is the negative of the tangent of this, which means if we take a tangent graph and we shift it pi over 2 to the right and reflect it, we'll get cotangent. So negative cotangent is, again, it's basically the exact opposite. You know, you reflect it over again. So it makes sense that you're getting this. If you had that sense, you were correct. So I'm gonna try to get my graphs in here, but they're harder because they're more stretched out. I swear, if you want your graphs to look good, you got to compress the y-axis. It's the only option. I mean, I'm doing all right here, I think. I'm not angry with my graphs right now. Oh man, doing them in one shot. That's the worst one so far, I think. So like, what happened there? I don't know. I lost confidence halfway through is basically what happened. All right, your range, all reals. Could have done that like before you did anything really. So y is an element of the reals. Domain. Domains for cotan. Super straightforward. So you always start with an asymptote. So whatever your starting point is, that's going to be an asymptote. And then they always differ by one full period. So 3 pi over 4 times n, where n is an element of the integers. Then the domain is all reals, except you can't have that. Ah, God. I started thinking about how I hadn't put the negative sign, and then like my ability to write just went away. There's really pi in this? There is. What the heck? I don't know, like all of a sudden I was like, that can't be right. Oh, wow. What is going on? Do it. Here we go. 3 pi over 4n. N is an element. I'm just so excited to be done with this cotangent. Not gonna lie, cotangent, maybe not my favorite graph. Maybe not. Let's see what we can do if we check it on the calculator a little bit. So we want to redefine. Yeah, we ran into the that weird issue with the domain. So I think that'll happen again. My thought is that it's doing something like converting to tangent and like dealing with that somehow. A weird consequence of the way that I graph is that I have no sense of what the equation is while I'm going through the process. So I think that if I try to do f of negative 72 pi over 80, it should say undefined. It does, thankfully. All right. So if I add, let me do this. I'm going to do x. Oh, let's do, hold on. I got an idea. Just trying to show you some calculator things we can do here. Plus t, let's say, such that t equals, so I'm going to add an increment, 15 pi over 80. I should get a negative 2 here. And I do. If I add another increment, that's just adding 2 increments. So the increment times 2, I should get positive 2. If I add 3 increments, I should get positive 6. Feeling good about that. Let's just see what it says for domain. I mean, I'm feeling confident about our answer, so not super concerned. Let's see if it gives us 2 again. It does. What is that? That's so weird. I really don't know. Let me see if I just say f of x. Oh, that probably has something to do with it. It did some trig magic, and now it's dealing with this. And I think that's where our extraneous domain solutions are coming from. And that's kind of weird. So I don't even want to mess with that yet. When we get to something called 14 formulas, though, we will want to mess with that quite a bit. So let's go back to the notes and pretend we didn't even see that, because that was insane. That's where, like, you know, the calculator can do stuff, and so it does. But anyway, this is our graph of cotangent. I think we did a good job. And I will be back in the next video to do some different stuff, I think. We're going to write equations from graphs, which is a really important topic, actually. So looking forward to doing that. And I will see you in that video.